Students, today we are discussing one example of finding structural importance of a component. Let us consider a 2 out of 3 system. 2 out of 3 system will have uh, 2 out of 3 system. Let x, y and z denote the state of the components. It can be 1 1 1. Let it be system state, and the system can be in function state since 3 of the components out of 3 components are working. And suppose this is the situation. So what happens? The system will be in working state. Okay, suppose another situation, that is 1 0 1, then also system will be in working state. Another situation is 0 1 1, then also the system will be in working state. So, and another situation is 0 0 1. In this case, there is only one component is functioning, so the system will be in failed state. And another possibility is, in this case also there is only one component is working, so in that case system may be in functioning state, failed state. Another situation is, this is another situation. In this case also system will be in failed state. Okay, and moreover one more case is available, that is all the components are failed, then also system will be in failed state. So think about these 4 vectors. What is the specialty of these 4 vectors? The system will be in working when at least 2 of the components are in working state. Okay, this also 0. Okay, so now let us consider the component number 1, I equal to 1. Okay, we are referring component x. In that case, we know that with the component I equal to 1, how many vectors are there with the system functioning? With the component I equal to 1, the possible vectors are these 3 vectors. There when the system is functioning, and these are the possibilities. Okay, among these possibilities, I think this 3 comes there: 1 0 1 1 1 0 and 1 1 1. Okay, and how many possibilities are there with the component? This also comes there. This also comes there. In this case, system is functioning. At the same time, when component I equal to 1, this case is also possible. At the same time, in that case, system is in failed state. Okay, so let us consider the vector. This is the vector. What are the possibilities? 1 0 0 1 0 1 1 1 0 and 1 1 1. Among these 4 combination, what are the critical vectors? What are the critical vectors? Let us look, search whether this is critical or not. Is it critical? All these vectors are critical. Suppose this component becomes 0, then still system is functioning. Okay, and suppose this component becomes 0, then system will become 0. So this is critical. That means second one is critical. Okay, and suppose this component becomes 0 in the third vector, then also the system become 0. So the third vector is also critical. Okay, critical. Okay, these two vectors are critical. So how many vectors are there in critical status? Yeah, what are the critical vectors? 1 1 0 and 1 0 1. Okay, so among the four vectors with I equal to 1, that is 1 1 1, 1 1 0, 1 0 1 and 1 0 0. Among these four vectors, these two are critical. These vectors are the vector with I equal to 1. So, and among these four vectors, these three are path vectors. Among these path vectors, these are critical. These are critical path vectors. Okay, critical paths. This is critical path vector, and so our equation is, what is the equation for finding component importance? I think we have studied in the last class. Yeah, this is the equation. Okay, this is the equation. So this is exactly, in our case, this is exactly number of critical vectors divided by 2 raised to n minus 1. So in the case of component I equal to 1, this is nothing but, yeah, this number will be I equal to 1. This number will be, what is this number? Yeah, how many critical path vectors? 2 critical path vectors among 3 path vectors. So sorry, among 4 vectors with the I equal to 1. So there are 2 critical path vectors among the vectors with the I equal to 1. Okay, so what will be the what will be the component importance? Yeah, 1 by 2 is the component importance. Okay, and due to symmetry, we can say that this is the similar argument holds for the component 2 and component 3 also. Okay, similar argument holds for the component 2, for the component 2 and component 3. Okay, so that is a an example. Now let us look at this structure, that is x1 into x2 union x3. X1 into, so what is this case? What is this example? Example of 2 out of 3, not 4, 3 system. That means at least 2 components should be in working state. For the functioning of system. Another situation is uh, another situation is I will I will draw a diagram. The system structure will be Yes, this is X, this is Y, this is Z. So what is the structure function of this system? X into Y union Z. Okay, Y union Z. Okay, so this is the structure function. So let us look at the uh, structure. X, Y, and Z. There are possibilities. Similar possibilities calls for this system too. Hmm? Okay. We have to determine these values. Suppose component 1. Suppose component 1 is in working state. Hmm? And 2 is in working state, and X is working state, Y is Y working state, Z is in working state. Then what happens? Yeah, the system will be in working state. Okay, system will be in working state. And suppose X and Y are in working, and Z is in failed state. So still the system is working. In this case, 101, 1 is working, 2 X is working, Y is not working, Z is working. In this case also the system is working. In this case system structure is because X should be in working state, otherwise the system will not be in functioning state. In all other cases we have this is the situation of this system or structure function of this system. Now let us look at the critical vectors corresponding to uh, what is that? Let us take one. Let us take one element 1. Okay, how many components are there with I equal to 1? Yeah, there are 4 number of components. 1. Which are them? Yeah, this is 3, and this is the last one. Okay, so how many vectors? 4 vectors. What are the vectors? 1 1 1, 1 1 0, 1 0 1, and 1 0 0 0. So among the 4 vectors, which are critical? Is this critical? Is this critical? Definitely it is critical, because if it goes to it is why if it goes to 0, then system it goes to 0. Okay, and if it is goes to 0, the system will go to 0. If it go to 0, then also system is in failed state. Okay, so these 3 vectors are critical. These are critical vectors. Okay, so what will be the importance of that component? Hmm? What is the importance of that component? Yes, that is number of critical vectors. Number of critical vectors. That is 3. Sorry. this is 3 by 4. Okay, now let us consider the second component. Second and third are symmetrical, so we need only to check the, here we considered I. We consider the situation of when I equal to 2. When I equal to 2, when I equal to 2, what are the critical factors? Yeah, these are paths. And this is, so these are the four vectors with I equal to 2. So what are the vectors? 1 1 1, 1 1 0, 0 1 1, another is 0 1 0. So among the four vectors with I equal to 2, which are critical vectors? Is it critical? No, when it goes to 0, when it goes to 0, sorry, when it goes to 0, what happens? The system still in working state. Okay, and in this case, when it goes to 0, the system will be in failed state. In this case, when system goes to 0, then still the system will be in failed state. But in this case, we need not to consider, because it is all the system is already in failed condition in this case. So we need not to consider this case. Just consider 1 1 0 and 0. So the four possibilities we are considering. So then one, only one zero. I put a point here only because when we it becomes 0. So I just note. So which are critical? These two are critical. This is critical. This is not critical. Yeah, this is also critical. This is not critical. At the same time, this is critical. And so only one vector is critical. Okay. So among the four components, only one vector is critical. So what will be the importance of component number 2? 1 by 4. Symmetrically, since 2 and 3 are symmetric, so we can consider the same argument for the identification of structural importance. So this is the example of X into Y union Z system. This system. Okay. So we have obtained. So which component is more important? Which component is more important? Give more important to the first component. We should give more repair maintenance activities for the first component. We should more give more care. Okay, so that is the advantage of identification of these components, more important components. Okay, we can identify the components with, what is that, more importance, so that we can give more maintenance, repair, replacement activities. Okay, to keep the system alive always. So, and you know that in my research work I have proposed one measure for the multi-stage system for identification of joint importance of components. You are not studying that joint importance. The research level, there is plenty of work available in joint importance measures. I have proposed some joint importance measure for the binary and multi-stage system in my research. It is available in the book, in a book. It's Advances in Safety and Performance of Complex System. In that book, you can see that joint importance measures. Moreover, I have recently introduced some measures. My area of research is concentrated on joint importance measures for so it is available in the different type of journals, and I have presented that result in BARC, Baba Atomic Research Center, during my PhD work, and it was published in the book Advances in Applications. Measure to the multi-stage system. This is my first PhD publication. Okay, and after that I could publish several works in joint criticality important measure MEMS and the joint measure K-out of system, and recently I could publish. Yeah, this is another paper, OpSearch. It is available in OpSearch. You can see whether I don't know whether this is available or not. It is not. And another this is joint model for network system, and recently I could publish two works. Yeah, this is Bernaba importance measure for multi-stage system with Professor Manoharan, and on yeah, this is a new work. Joint important measure for multi-stage system in International Journal of Statistics and Reliability. So my work concentrated on the structural and reliability importance of different systems, different multi-stage system. The basic framework is taken from this part. Okay, basic ideas and terminologies I have taken from this work. Okay, anyway, I stop this presentation now today. There is a scope for studying reliability theory, especially in importance measure. Importance measure, reliability importance is there, structural importance is there, multi-stage system importance is there, and several books are available. Importance measure books. I think this book, in this book you can see this is the book available in online, and this is available online library. They have cited my work in this book, hmm, about the importance measure. In one of the chapter they have mentioned our work. Okay, so there are plenty of opportunities available in the area of reliability theory. Many of the statisticians and mathematicians, reliability engineers are working in this area. So this the book we are currently using is the book of Barlow and Proston. Barlow. Mathematical theory is available online. I think it is available online. Barlow and theory of reliability. I think this is available or not. Let me check that. The PDF is not available at the same time. Let me try for the book. If it is available, if I can download this book, I will send you. No problem. Let me do this. No, this is only the. It is available in our library. We have purchased one book, Mathematical Theory of Reliability, and we are referring statistical theory. Wonderful book, a research book. It is a I don't know whether this is available. No, it is only a publication. If you want, you can look at this publication too, because all the ideas are mentioned there. Yeah, this is that book, and I don't know whether this is downloadable or not. And I have taken the photos from Cochin University in 2006. Going to all this. So this is a example only, and I will send this video to you